For those of you who don't know me, quick introduction. My name is Bernd Giesecke. I'm working for RAKwireless now since 4 years, and I am the product owner of our WisDuo modules, our WisBlock modular system, our WisTrio cellular devices, and of our internal developed firmware RUI3. And today I will give an introduction how to use our WisDuo modules. I hope it is helpful for everyone. What I want to cover is basically a guideline how our customers can integrate the WisDuo modules into their own devices. I will cover the integration on the hardware side, what is the minimum required. I will also show some best practices regarding the communication with these modules, and I will give an introduction into our RUI3 firmware, the API, which allows you to write your own applications for our WisDuo modules. So I'm assuming you all have heard about our WisDuo modules. Basically, it is a small stamp module which integrates a microcontroller and a LoRa transceiver. And they can be used different ways. For our smaller modules like the RAK 172, very often it is used together with a host microcontroller. Can be an ESP32, can be a more powerful STM microcontroller. So in this case, here, this is where our module acts basically like a modem. It is just the communication modem for the host microcontroller to send and receive LoRa or LoRaWAN messages. However, a growing number of our customers is using our WisDuo modules as a standalone microcontroller. So in this case, there is only the module itself, and it can directly talk and connect to sensors, actuators, displays, keyboards. And an example of such a standalone solution is what I show here on the right side. Custom device. It is in this case a RAKwireless device where the stamp module is the only microcontroller in the system, and it takes control over the communication. And for those of you who are familiar with WisBlock, you can see here interfaces from WisBlock, so we can put in here WisBlock modules. This node device can directly communicate with them, collect sensor data, work with actuators, and run their own firmware. In the first slides, I will go into how customers can integrate our WisDuo modules into their own designs. We have designed the modules to keep the requirements for external components as small as possible. As an example, for a 3172, you only need a few capacitor, one resistor outside of the module to get it to work. And then at that point, it can already be connected over serial connection, the UART, to a host controller, and work together with this host controller in a custom design. Same for the 11720, the Apollo 3 module, which is a little bit more powerful than the 3172, and it has, in addition, Bluetooth connection available. Now, depending on the design, we didn't show this here, but depending on design, it might be required to adjust the path from the RF pin to the antenna itself. I will go a little bit more into details about this part. It's not always required. For example, if you use our WisDuo modules with the IPEX connectors, this part with the RF path adjustment is not required. If you use the modules with their RF pad and you connect the antenna there, then you will need such an RF matching circuit that is shown here. The 4630 is similar to the 11720, a module with a more powerful microcontroller, more flash memory, more RAM available for applications. It is a little bit older module than the Apollo 3, the RAK 11720, and different to the other two modules, it requires two supply voltages. One main supply, which should be slightly higher, that is needed for the internal DC-DC converter of the 52840. There are other solutions I will show later while we're going through. But beside of that, the external components required are basically only capacitors and the reset circuit. And then it can be connected to another host controller. where from experience, most customers that buy a RAK 4630 or buying a RAK 11720, they are using this module as the main microcontroller in their system. It is more on the RAK 3172, which has limited memory capabilities and also running on a lower frequency that is used as a plain modem. And yeah, last one is our RAK 3172, which is different from the other WisDuo modules I mentioned up to now, because the 3172 is not a stamp module, so it's not a small PCB that you solder on top of a custom PCB. This one is a SIP module, more like a chip. And because of that, it is a little bit more complicated to implement it into custom design, because you need quite a number of external components to get this SIP module running. For example, in our stamp modules, we have all the components for the power supplies integrated. If you use the RAK 3172, you have to add external inductors, capacitors, and connect them properly to get the DC-DC power voltage regulator running on the RAK 3172. For the supply voltage ranges, for the 3172, 3172 SIP, and 11720, it's basically 1.8 to 3.6 volt. So it can run directly from a battery, small batteries even. However, for a more stable system, we recommend to have a regulated power supply on this step. But both ways is possible, and we have customers that run them directly from battery. There are a few limitations, but it is possible. For the 4630, as I mentioned earlier, it's a little bit more complicated, as we need two supply voltages, VBAT from battery or USB in the range of 2.5 to 5.5 volt, and a second voltage from between 2.0 and 3.6 volt. The first voltage is mainly used on the microcontroller in the 4630, the NRF52840, and is required for its internal DC-DC voltage regulator. The second voltage VDD is used on the Semtech LoRa transceiver inside this module. Okay, next one, using the WisDuo as a standalone module. So it can be used like this. It has a microcontroller, it has the LoRa transceiver. We have an application firmware that can be developed with our RUI3 API. The modules have all I2C, SPI, UART, and GPIOs available, can be controlled with the RUI3 API. Pin assignments for these different IOs can be found in our documentation. I have listed all the links here. And yeah, what I highlighted here is actually a frequent problem that we see. One of the pins that is available on the RAK 3172 is actually used to determine whether the module is a low frequency module, so for CN 470, EU 433, or if it is for a high frequency range from 800 to 900 megahertz, like EU 868, US 915. Now, this pin is available on the stamp module. However, it was placed there for our factory so they can check during the production that they are using the correct module, low frequency or high frequency. Now we have customers that use this pin for their own applications, which is in general possible, but it is important that during power up of the module, this GPO should not be pulled down or pulled up. Otherwise, the module might be initialized in the wrong frequency. If you use the WisDuo module together with a second microcontroller or host microcontroller, basically only 4 connections are required. The power supply, 3.3 volt, ground, and a serial connection, which runs with 115,200 baud. We recommend, beside of these 4 pins, to control the reset of the WisDuo module as well. It is rare, but it can happen that the WisDuo module is becoming unresponsive. If the host microcontroller can control the reset, it can regain control over the WisDuo module. Another should be normal. The power supply of the WisDuo modules is 3.3 volts, so the UART, RX, and TX lines, they are only for 3.3 volt. So if a host MCU is 5 volt levels on its GPIOs or in its UART, voltage converter is required. And the last thing, the 4630, again, is a little bit different and special. It can communicate with a host microcontroller with 80 commands over its UART2. However, firmware updates are only possible over the USB port, and that has to do with the internal structure of the microcontroller and the bootloader that is running on the module, which allows firmware updates only over the USB port. Now, to prepare custom hardware for firmware upgrades, whether it is standard 80 command firmware or if it is a custom firmware, there are a few requirements. On the RAK 3172, 3172 SIP, the update can be done over the UART of the module serial port. Only one UART is supported, the UART2, and updates can be done with our WisToolBox application. The other option is to use the SWD interface with an adapter like a DAP-Link or a J-Link programming adapter. And for the 3172, it's also possible to use the STM32Cube programmer either over the UART or over the SWD interface. If you use the UART, the only thing required is a UART to TTL adapter, USB to TTL adapter to connect to your computer. STM32Cube programmer also supports the STM32 specific programming tool, which is using then as well the SWD interface. For the 11720, it's quite similar, only the STM32Cube programmer will not work with it. And for the 4630, as I mentioned earlier, firmware updates are only possible over USB and can be also updated over the SWD interface with a DAP-Link or with J-Link programmers. Now, for these three options, if you use the UART, basically what you need for the update is only the RX and TX lines and the ground signal connect to a computer or to the STM32Cube programmer. If you want to use the SWD interface, you have to expose different pins, which is the clock, the data, reset line, and ground to be able to use a DAP-Link or a J-Link programming adapter. Yeah, one slide about the antennas, and it's also frequent questions from our customers. We have all WisDuo modules available with IPEX connectors to connect an antenna directly to the stem module. But alternative, you can order the modules without this connector. In this case, the antenna has to be connected through the RF pad. Now, where we hear frequently from customers that they have problems, they think they can use an IPEX, a WisDuo module with IPEX connector for initial start, and then just later on use the RF pad on a module with IPEX connector, and that is not possible. These two options, they are exclusive. If the module has an IPEX connector, the RF pad is not connected to the RF signal. If an external antenna should be used, the WisDuo module has to be the variant without the IPEX connector, and then the RF signal is on the RF pad. And in this case, you require an RF pad path matching from the pad to the antenna or antenna connector. And in general, there should be no ground layer directly below the RF pad. Now, to make this step easier for customers that want to use an onboard antenna or connect their own antenna through an SMA connector or something else, we are actually offering an antenna RF designs, which covers the RF path matching, but it also offers you to design custom antennas. For example, this is the same device I showed earlier with a stem, with our stem module on it. So we can design for you PCB antennas that are connected to the main PCB, and they can be customized, and they can even be a wide range. For example, this antenna is working from 863 to 928 megahertz, which means you can use it for most LoRaWAN regions, EU868, US915, AU915, AS923. All of them will work with this antenna with a good performance. We are also supporting in the design of an antenna directly on the PCB of the customer. So we can design this antenna, optimize it, give the antenna matching circuit, calculate everything. In this case, we will collect information from the customer. We will do the design. We will provide files that help him to integrate the antenna into his PCB in different formats, whatever the customer is needing. And once he has the first prototypes, we offer to test these first prototypes with an integrated antenna and make adjustments on the RF path matching if required. And the more simpler way is if the customer wants to use a different antenna connector, like an SMA connector, we can support in the design of the RF path from the RF pad to the antenna connector itself. Actually, the title on this page is different. It's wrong because I'm going here now already into WisDuo AT command firmware. As I had mentioned earlier, we have developed our own RUI3 firmware, which is also offering framework and API for custom applications. We are maintaining this firmware really actively, and it is not official yet, but we will offer the RUI3 firmware with a LoRaWAN stack update to version 1.0.4 soon. New releases are available at the moment around every 4 to 6 months. We are announcing these new releases in the documentation center together with the change logs. And also in these change logs, the customer can find if there are any breaking changes, which we try to avoid. But sometimes it is required, as, for example, AT commands are slightly changing, or more on the API side that function calls are changing. So this is also announced in the documentation center in the release notes. It is possible for our customers to subscribe to this, to receive notifications if we release new RUI firmwares. And in general, the customers can update firmwares without erasing the preset device configuration. So even if the device is in the field and customer wants to update the firmware, he can do this. The device configuration, like device EUI, which LoRaWAN band it is set up, this is all saved and survives the firmware update. Okay, this slide is basically the same I already showed earlier, the different ways to update the firmware. Just 2 slides about WisToolBox. It's an application that we developed, which is running on desktop computers and mobile devices at the moment, available for Android and iOS. And it is a helpful tool to set up and update WisDuo modules. The desktop version works with all WisDuo modules. The mobile version works at the moment only over BLE with the 4630. But I know we are right now implementing the support for the RAK 11720 for firmware updates and setup of the module over Bluetooth. Offers multiple functionalities. We have the firmware update, which can be done through an easy-to-use UI. Also, WisToolBox is automatically updated when we have a new firmware release. So you will always find the latest firmware version in WisToolBox. You can also flash custom firmware through the WisToolBox using the same user interface. And you can also create templates within WisToolBox, so you can reuse the same LoRaWAN or LoRa P2P settings, regions on multiple devices. So it's much easier to set up if you have a larger number of modules that you need to initialize. And for debugging, also offers an integrated terminal that can be used for manually set up with AT commands or debug output. Okay, yeah, this is a little bit too small to see. So basically the different steps working with WisToolBox. First one is connecting, selecting the module. Usually this is automatic. Then you have the option to set up the LoRaWAN or LoRa P2P credentials and settings like frequency. And you have the option for the device firmware updates. And you can use them as well for custom firmware updates. As I mentioned earlier, it is possible to update the firmware through WisToolBox and serial connection, but more applicable for larger production for manufacturing is to use the J-Link connection. So to use the J-Link connection, as I mentioned, you have to make available the SWD interface of the module and connect it to a J-Link adapter. So these pins here, these pins should be available as a pin header or solder points, connection points on the custom PCB for the customer to use this J-Link option to update the firmware, which is also much faster than going through the serial communication. An important point is, especially with J-Link is not providing a voltage supply to the module. It is only reading the voltage as a reference. So in this case, an external power supply is required for the update. For J-Link, as I also experienced a lot of questions from customers, what are the settings if using J-Link? So I listed them all of here. Which microcontroller has to be selected for a 3172, for SIP module, which is using a different version of the STM32WLE, for the AMBIC, and for the Nordic. When you use the WisDuo modules with a host microcontroller, the communication between the two is over AT commands and the serial connection. There are some basic rules that I collected or I wrote down here, also from experience with daily work with customers. Number one, when sending commands to the WisDuo module, every command has to be terminated by carriage return and line feed. And unfortunately, very common problem is that customers sending AT commands one by one, just very quickly, without waiting for any response from the WisDuo modules. But this communication, this AT command interface, it is a communication protocol. There is one way towards the WisDuo module, and the WisDuo module will always acknowledge the command or give an error message. And during the communication, it's very important that after sending a command, the host microcontroller should always wait for the response. Otherwise, the communication will be messed up and can lead to AT command not found or other malfunctions, AT commands misinterpreted. So it's very important that always wait for the response. Very important. And in addition, beside of the AT command protocol, the WisDuo module will also send asynchronous events through the UART to the host microcontroller. For example, if it received the packet, or when switching the mode to class B, it will send the current status of the class B mode back to the host microcontroller. So it's also important that the host microcontroller should be able to catch these asynchronous events as well to know about the status, what is going on. Very simple example for device setup with AT command interface. Actually, when using LoRa P2P, only 2 commands are required. For LoRaWAN, it's a little bit more complicated. You need around 8 AT commands. This is the very basic setup. With doing this, you can start. There are many other AT commands that can configure other aspects of the LoRaWAN communication and of the P2P communication. But these 2 or 8 commands, these are the basic commands. After using them, the module will be able to communicate and to receive data. Now, using these AT commands, settings are saved in the flash memory if they are changed, and they will be automatically reused after a reboot or power cycle. So this cycle of setup has to be done only one time. Then the module will have them saved and reused. For using the device after the setup and after it has connected, there are also only very few AT commands required. So on P2P, we have to command AT plus P send to send a data packet, AT plus P receive to switch the module into RX mode so it can receive packets coming in from another P2P module, which can be any LoRa P2P capable device. It can be a non-RAK wireless module as well. It can be a device set up with a complete different LoRa transceiver, as long as the transmission data, the transmission configuration is the same. One special thing that we added is the AT plus P receive command with this specific number. This is coming from a customer request because in the early stages with the AT command, you could either have the module in receive mode, and every time you wanted to send the packet, you have to stop the receive mode, send your packet, and go back to receive mode. So we added this AT plus P receive 65533 command, which is putting the module into RX mode, but you can still use the AT plus P send command to send data. So what is happening in this case is the module will switch from RX to TX to transmit mode, send the packet, and then switch automatically back to the RX mode. So this is for application flows, this is much easier. For LoRaWAN, it is very similar. We have the send command to send the packet, And we have the AT plus receive, which will give you the last received data packet. Now, using AT plus receive means that the host microcontroller would just guess if there is a packet there. It uses it to check if a packet was received. And it is much better if the host microcontroller can wait for the asynchronous events that are also triggered if a data packet is received. And this is triggered in all modes, in class A, class B, or class C. Whenever a data packet is received, the asynchronous event will tell the host microcontroller that a packet has received. Yeah, short example for LoRaWAN. So here I set up the device for AS923-3, data rate 3, and so on. So with a few commands. The last command, AT plus join, is used to connect to a LoRaWAN server. Once this command is sent, the WisDuo module will respond with an asynchronous event. So after I give this command, AT plus join, to the WisDuo module, it will respond with OK. But in that case, it doesn't mean it has already joined the network. The host microcontroller has to wait for the asynchronous event, which will actually tell whether the join to the LoRaWAN server was successful or not. So the first one obviously joined. The device has joined the network. The second one, TX timeout, is more like a critical error because it couldn't send the join request. RX timeout means it didn't receive the information from the LoRaWAN server regarding the join request. And in some cases, like when a packet is coming in from the LoRaWAN server, but for example, there's a CRC error or it is cut off, then you would get a specific error number, XX here, that tells you the join failed because of that reason. So going on with the LoRaWAN example, once you have joined the network, I can use the AT plus send command to send data to the LoRaWAN server, where there are two parameters. The first one is the F port, which port should be used to send the package. And the second one is the data packet itself. Now, as AT commands are ASCII format, if you want to send the hex values 30A32 as your packet content, you have to use the ASCII equivalent of these bytes in ASCII in hex format. So you would send AT plus send is 2 double point and then 300A32 as ASCII. Again, here an AT plus send will respond immediately with OK, which doesn't mean the package was sent. Again, the asynchronous events here are getting important because it will tell you whether the transmit is finished for an unconfirmed upload, or whether the transmission was finished and it got an acknowledge from the LoRaWAN server in case you're using the confirmed package mode, or if no acknowledge was received, it will give the send confirm failed. To tell, okay, I sent the package, but I didn't get the acknowledge from the server. When data downlinks is coming from the LoRaWAN server, they are reported by an asynchronous event. I mentioned this earlier. Now, depending on the LoRaWAN class that is used, the response, the asynchronous event, will look slightly different. In class A, where a device will only be able to receive data after it has sent its own packet, the event is RX underscore, and then comes the RX window. So there's a window 1 or window 2, the RSSI level, the SNR level, which transmission mode was used from the LoRaWAN server. It was unicast, so only to this device, or if it was multicast. Then the data itself, again, the received data here mentioned as AABB is an ASCII formatted string, which has to be then translated to its corresponding hex values. So if your device receives 300B32 as an ASCII string, the values will be 30 hex, B hex, 32 hex. Okay, the same for LoRa P2P. So we set up the device with one command, AT plus P2P, with the frequency, the spreading factor, bandwidth, coding rate, the preamble length, and it transmit power. And then we can set the receive to continuous receive with transmit allowed. Now here it's suggested to reset the device and restart the listening. And then for the next step, the device is ready to receive LoRa P2P messages, and it can send LoRa P2P messages. Now, LoRa P2P is very different to LoRaWAN in the case that it doesn't have protocol. It is just sending out raw data. So the send command is simpler. It's just having the payload itself, again, as an ASCII formatted string of the hex values that should be sent. Once the package is this command is sent, it will immediately respond with OK. However, to know that the transmission has been done, again, asynchronous event will be triggered and sent back to the host microcontroller to say TX P2P done. If data is received from another P2P node, it is again triggering an asynchronous event, which will give the information we received data over P2P with this RSSI level, SNR level, and then the payload, again, as an ASCII formatted string, it has to be converted into the hex equivalents. Now, if you don't use it, to use the WisDuo modules with the AT commands, you can also use the RUI3 API, which is a tool that we developed, that we use by ourselves to develop the AT command firmware for WisDuo and WisBlock, but it can also be used to develop your own custom firmware. When using the RUI3 API, it has the complete functionality to connect and communicate over LoRaWAN or LoRa P2P included, same like the standard AT command firmware. You have access to the same AT commands that you know from the AT command firmware, so that is always included. So it's also, even if you have your own custom firmware, it is easy to do the setup one time in the beginning with the AT commands. And the advantages for when writing custom application, the customer does not have to implement the LoRa and LoRaWAN functionality by himself. RUI3 is complete open source. It is available on GitHub, and you can use it for free, and you can customize it for your own needs if you require. You can use the RUI3 API as an Arduino IDE compatible board support package. You can use it with other development tools like Visual Studio Code to write and compile applications with CMake. So you don't need to rely on Arduino IDE, which with some customers has the label of not reliable, not good for a serious development of application code. So you can work directly with CMake and an IDE like Visual Studio Code to write your code and compile applications by yourself. Now, why did we do our RUI3? Number one, as I mentioned, is of course we needed a firmware that is implementing all the LoRa and LoRaWAN functionality and offers the AT command interface to set up our WisDuo modules when they are used as a plain modem. But we offered it and we extended it to have these API function calls integrated so that companies that have experience in developing their own software can easily extend this API with their own firmware, read sensors, control devices. They don't have to have the deep experience how to implement the LoRaWAN stack or LoRa communication. So with RUI3 API, we try to take the pressure off the development and also provide them with a tested LoRa and LoRaWAN communication that they can immediately use. So if you don't want to use RUI3, basically you have to develop not only your control and sensor and actuator software, but you have also to implement the interface and the LoRa software or LoRa stack by yourself. So what we are trying to make the life easier for our customers is we take care of the LoRa, LoRaWAN and interface, and the customer can just concentrate on how to use his sensors and actuators and write his control software, when to read sensors, when to activate an actuator or deactivate it. To make it easier to start with our RUI3 API, with the board support packages, we have a large number of simple examples that just show how to use the API. They are intentionally kept simple, just to show different aspects of how to use our RUI3 API, how the different function calls are working. So this is like the quick start step into RUI3 API. Now, to give more ideas how to use it in more complex application, we are also offering a collection of really applications that can do things like control actuators, like RUI3 controller relay. We have an RS485 Modbus example. We have advanced sensor application here that can be used as an indoor air quality example, can measure CO2, particulate matter, temperature, humidity, VOC. We have examples for location trackers, example for alarm contact applications. So we have here a wide range of application examples that the customers can use and build upon them, enhance them, or strip them down, depending on what they need, to make their own application. And as an entry point, because that was also where customers using RUI3 API, when they started, were struggling, is what are the best settings for the lowest possible power consumption. So we have here also an example that shows what is the best practice to achieve the lowest power supply, lowest power consumption on a WisDuo module. And also in the same, all of this is in our GitHub repositories, and we have also some tips and tricks if you want to use the Visual Studio Code instead of Arduino IDE. Okay, this is now frequently asked questions I collected from customers. Very common question when customers start creating their own PCB is, where can I find PCB design libraries for the WisDuo modules? Now, we decided we don't want to step into this by ourselves because there are so many different PCB development tools outside. We cannot really provide PCB library for each and all of them. So instead, we are using available services like SnapMagic and the component search engine, and they are providing the PCB design libraries for our stand modules, the 4630, 3172, 3172 zip already. So you can download them from these providers. They are free, and they are supporting basically all of PCB design applications that I have heard of. An exemption right now still, unfortunately, is the 11720, but the pinout of that module is the same like the 3172. The only missing part is the Bluetooth antenna pin. But in principle, the 3172 pin out can be used for the 11720 as well. We're also providing 3D files for our WisDuo modules because it is not only the PCB that has to be designed, but you also need enclosure. You need to make sure everything is fitting into your enclosure. So we are offering the 3D files for all of our modules in our download center. And another question was, it's always a question, the certifications for WisDuo modules. So we have certifications, usually at least CE, UKCA, FCC for our WisDuo modules. The basic certification documents can be found as well in our download center under the folder LoRa, and then on the specific subfolders for the 4630, 3172 zip module or 11720. More frequent questions, where can I find the data sheets? The data sheets are all in our documentation center. Where the reference designs, we have only reference schematics. We are not offering reference designs. And where can I get support? I know most of you know it. We have our forum, and you can reach us directly for technical support through email on support@RAKwireless.com. Okay, I'm running out of time, I just see. So I leave the rest of the FAQs open. So basically everything is either in our documentation center or in our GitHub repo.